Hello all, welcome to binaryhackers.com. So the DNS is work on the port number 53. It is a use TCP or UDP port number 53. This is a standard port of the DNS. So in this video of the Wireshark training part 12, I'm going to discuss about the structure of the DNS and how it's actually work. So first start the Wireshark in your system and start the capturing packet and go to the website. For this video I am using a facebook.com. You also use a google or yahoo.com. After that, stop the capture packet and you can see there are lots of packet in the packet list pane. So in this video I am going to discuss about the DNS structure. So the packet number 3, you see it's a DNS packet and it's a standard query packet. You can see on the information field is a standard query packet and this is a transaction ID of this packet. The ID is 1C01. The query standard query packet and standard query response packet, the both packet contain the same transaction ID. The A means it's a host, that is the host record, and host is our www.facebook.com. In the packet detail pane, you can see it's a domain name system, it's a query packet. Now just expand that field. This is our response in number 4. So this is, I selected a first packet. Okay, it's a packet number 3. This is a DNS query packet and it tells that it's response packet in the packet number 4. So in packet number 4 this is a DNS query response packet. So this tail in this field. The transaction ID is same in the response and the query packet. So in the response packet the transaction ID is same and it's still that it's go back to that particular query. So this is a flag field. Let's expand it. The first is our 0 field. It represents the message is a query packet, and the another second field is the 4 zeros. It is the opcode of the DNS, and the 40 mean that is a standard query. The 0 it's mean that it's a standard query packet. If there is a number 2 in the opcode, that it means that it's a server status request. If there is a 5, it means that it's a update packet. The next one is our truncated, so the message is not truncated. The next one is a recursion desire. It's a recursion desire, so do query recursively. Recursion is a process of making query for information of the DNS server. If that DNS server doesn't have the information, they will go on your behalf and ask another DNS server. So you don't have to go to ask multiple DNS server. You only ask one DNS server and it will ask another DNS server on your behalf. So this is a recursion and the recursion number is 1, so it is on. The next one is our result, that is a reserve 0 field, and the last one is non-authenticated data. It is a default result of non-authenticated data in the query packet of the DNS. After that there is a 4 field. It is a question, answer RRS, authority RRS, and additional RRS. RRS is actually a resource records. Resource records is actually a database record that you get back when you make a DNS query. After that it's a query field. Let's expand this field and you can see it's a facebook.com. Expand, and in your query field there is a facebook.com, name of the website, type A is a host address, and class IN is a indicate that it's an internet query. So go to this website, is ina.org, assignment DNS parameter, and you can see there is a lots of DNS type that describe the value of that type and meaning of that type. This is a record, it is type A, it's represented at the host address, same as SOA is for the start of zone of authority, like MX, it's a mail exchanger. So this site contain all the DNS type and meaning of that particular type. So this is our DNS query packet Now let's go to our second packet, that is a DNS response packet. So this is our DNS query response packet. Just expand this domain name system field. This is a response packet and tell that the request in 3. So in packet number 3, it's a DNS request query packet. It is a request packet, and for that request I send this response to this packet number 3. This is a timestamp of this response packet, and this is a transaction ID. Transaction ID is match, so we know that this response go to that previous query. This is our flag field. The first 3 or 4 field is the same as I already described in the query packet. This is a 1 for response. The opcode is a standard query. So recursion desire is 1 and recursion available for the server is 1, so it's on. This is our result that is reserved, and this is our answer authentication. The answer or authority portion was not authenticated by the server and not authenticated data, so it is unacceptable. If this bit is set to on, means it 1, then it simply means that the DNS server that responded has authenticated this information accordingly to its own policy. But this field is 0, so there is no authentication. The reply code is no error. So this is our 4th field, the question, answer, authority and additional. So in answer field, you can see, just expand this answer, there is 2, it's facebook.com and cr10 facebook.com. This is our answer RRS. In authority RRS there is 2, so authority, there is a name server, 2 name server of the Facebook. So first let's go to the query. This is our facebook.com name, type A is a host, class IN is the internet. In the answer field I'm going to discuss only one, because all the answer field are the same, only the value is different. So in answer field there is a name Facebook, type is CNAME, in class there is the internet, so 0001, and this is our time to live, TTL value is a 24 minutes. So this value tell the client how long they allow to cache this information. If the TTL or the time to live value is a 0, that means the client can use this information once and that's it. It's not allowed to cache any information. So this is time to live value. This is a data length, that is a 12, and primary name. So this is a simple DNS structure. I'm going to discuss one field right here. This is a recursive desire. So DNS query is for 2 methods, that is a recursion and the iteration. The recursion is happen of the client and the DNS server, and iteration is happen on the DNS server to the DNS server. So this is a simple structure of the DNS server. So this is the structure of the DNS, so domain name system. DNS is work on TCP or UDP port number 53. So in this video you learn that how the DNS query and DNS response packet is actually work. So thanks for watching. See you in the next video.